One thing I find students have trouble with is seeing that everything we learn about in stats is connected. So they learn central tendency, like means, and then they learn variability, like standard deviation. They don't see that those two things are necessarily bounded to each other. And then we learned about things like z-scores, p-values, t-tests, ANOVAs, regressions, and each time we move to a different word or a different test or a different equation, they just see it as a brand new subject that has nothing to do with what they've learned yet. So it really is important to connect these things together. I'm going to do that through flowcharts. So let's start really briefly with moving from a mean to a p-value in the context of a z-score. So the idea is we start off with a mean and we move to a z-score. But how do we do that? Well, we're going to use an equation. And this equation is this one right here. So we have our mean, our mu, and our sigma. Now the mu and sigma are things given to us from our population. Now, if you haven't gone this far as a student yet, all you really need to know is that these two numbers are given to you in the equation, or in the question, I should say. So these two numbers are given to you. You never compute these two numbers. You do compute this number, but we're going to wait a sec before we do that. But for moving from the mean that we've already computed to the z-score, we use this right here. The next thing is, how do we move from the z-score to the p-value? Now again, this might be a little bit further than you know at this point, but with t-tests and stuff like that, and ANOVAs, we use p-values as a value to determine our conclusion. So with inferential statistics, things like z-tests and t-tests and ANOVAs, things you might have not heard yet, we're really just trying to see if two things are different, or two or more things are different. So is group 1 different from group 2? We use these p-values as a criteria for that. So for example, if the p-value is less than 0.05, we say those two things are different. So group 1 is not the same as group 2. Again, this is a little bit more advanced than you probably are at this point, so don't worry too much about it. But how do we get to our p-value from our z-score? The answer is our z-table. So really briefly, we can look at this z-table here, and we can start by looking at these columns and these columns and these rows here. Now your z-table might look different, that's okay. Same idea. Essentially, let's say we have a z-score of 2.01. So what we do is we start with these rows. So we look for 2.0 right here. Not 2.1 because we're looking for 2.01. So this is 2.0, and we go across this to find the 1. So 2.00, 2.01, 2.02, 2.03, and obviously we're looking for 2.01. So we find 2.01, and this is our p-value. So we use the table to look up our z-score so we can find our p-value. But this can happen in reverse as well. So I can instead give you a p-value, and then you could find your z-score from that p-value. So for example, if I give you a p-value of 0.7704, which you're going to have to scan through all of these to find it, but it's right here, what is our z-value? So it starts here, so 0.74. So our z-value is 0.74 based on this p-value. So not only can we use the z-value, to move from the z-score to the p, but we can also use the z-table to move from the p back to the z-score. Now finally, what if you start with p like we just did and we found a z-score, and we want to move back and figure out what our mean is. So we didn't calculate our mean, but we do know these two things. And so can we actually calculate the mean from what we know? And the answer is yes. So we're going to trace back from the z-score to the mean. And I forgot to put a z-table here. So to move from our z-score back to our mean, we can use this equation, which is z times our sigma plus our mu. Now let's work through this. So I already told you that we already know our mu and our sigma because that's given to us in our equation. So in the professor's question that he gave you. So let's give it to you. So I'm going to give you the idea that our mu is going to be 5 and our sigma is going to be 2. Okay? And then the mean is probably something you're going to have already computed, but it might also be given to you. But I'm going to just put it here. So let's rewrite the equation. And let's plug in the numbers. So our mean is 9 minus our mu, which is 5, divided by our sigma, which is 2. So 9 minus 5 is 4, divided by 2 equals 2, and 2.00. So our z-score is 2.00. Now what we're going to do is we're going to use our z-table to find our p-value. So our z-score was 2.00, so we're going to find 2.00. And that corresponds to our p-value of 0.9772. So let's write that in here. Our p-value is 0.9772. And there we go. That's moving from our mean to our z-score to our p-value. But of course, we can move backwards as well, from our p-value to our z-score to our mean. So now let's start off with a new mu, which is going to be 10, and a new sigma, which is going to be 3. So we're also going to start off with a p-value of 0.9505. So we're going to move to our z-table to find our z-score. So again, in the middle is a bunch of p-values. So we're going to have to find that 0.9505, and that ends up right here. So we can find our z-score by looking at both the rows and the columns that correspond to this number. So let's start with the rows. So 0.9505 p-value corresponds to a z-score of 1.65. See that? 1.65. So let's write that in here. So 1.65. Now we can use this new equation here to find out what our mean was in the first place. So we're going to add the z, the sigma, plus our mu. Kind of looks like a 6 is a sigma. So our z is 1.65 times our sigma, which is 3, plus our mu, which is 10. So that equals 4.95 plus 10. So 1.65 times 3 is 4.95 plus 10 equals 14.95. And that is our mean. So now not only have we moved from our mean to our z-score to our p-value, but we're also able to move from our p-value back to our z-score back to our mean.